Our question is, what is the reason for using the 17-inch monitor in the multimedia systems, and what is the benefit of having a color scanner?
All right, well, I'm glad you asked that question. Normally, I ask my department chair to have two 17-inch monitors instead of one, because as you start working, for example, in director or author, you will realize that you have your tools and then you have the end product. And it always helps to have a larger monitor so that you would be able to look at the end product as you are working with the tools on the same screen.
And we have a question from Brazil, the Serviço Nacional de Aprendizagem Comercial. Welcome. Your question, please.
Buenos días. ¿Cómo es que los medios de la televisión se incluirán en el
Yes, if we could have the question repeated, please.
How will the digital television be included in the context of the multimedia?
Okay.
Digital television is a means of transmitting high-quality audio and video, and so therefore it'll be a major factor in presentation of multimedia to large audiences.
And we have a call from Toluca, from the Cerveceria in Toluca. Welcome. Your question, please.
Hello, good morning. We are already using multimedia systems with Toolbook to be able to have interactive training in our plants. We would like to know, what do you recommend in order to store these interactive courses? And what equipment we should use to edit video? Because we have encountered problems here.
Okay. Storage devices that I recommended during the presentation was either a 1 megahertz or a 1 megabit actually storage device that is made by iOmega. That's one thing that I recommended. As far as editing device is concerned, we are using Media 100, and I'm not sure whether that's available to you, but that is something that we have had in our department for a number of years, and it has been very useful and effective for us.
Yes, the Media 100 seem to be extremely popular right now among people I know. We have time for one more question right now from the Universidad de Monterrey in Nuevo León. Welcome. Your question, please.
Yes, my question has to do with the creation of multimedia applications. Is there any publication or school that can assist you or teach you to create this type of electronic media?
Okay.
Well, I'm going to be impartial and objective. Yes, my Department of Educational Technology at San Diego State University is a very, very good source of multimedia training, and we have our certificate program online through the web available internationally.
Thank you for your excellent questions. We now turn to Module 2, in which Mr. Mahon will describe the development of electronic mail, video conferencing, and more recent open systems with integrated platforms and numerous varied applications for business, government, or education.
Thank you. Information technology has changed with the integration of the computer and telecommunications. Let's review a bit of the history. In the early 70s, the U.S. Department of Justice began the deregulation of the United States telecommunications industry with the breakup of the regional Bell companies. The breakup produced AT&T as the sole long-distance carrier and 7 regional Bell operating companies, or Reeboks, for local access. I think it is fair to say that this was the beginning of the explosive growth that we now see on every continent in the world when we discuss telecommunications. This breakup of the Bell companies was also significant in that it opened up what was a regulated market to competition and allowed MCI to compete with AT&T. This event also signaled the beginning of the world is seeing today with the rapid integration of telecommunications and computing into a multimedia communications device. For those of you who may not know, Unix, which is one of the leading operating systems for computers, was developed by Bell Labs to manage telephone switches. It was the U.S. government that denied telecommunications companies the opportunity to compete in the computer industry. As many electronic engineers will verify, a telecommunications device, such as a private branch exchange or PBX, a telephone switch, is just another computing device based on microprocessor technology. In those early years, none of the engineers working in the telecommunications industry ever envisioned the blending of computing and telephony equipment into a set of services and products that today are referred to as multimedia services. Today, this integration of general-purpose computing and telecommunications devices are used daily by business and government in a worldwide mesh of electronic voice, video, and data devices, commonly referred to as the enterprise. I believe that this is quite common for many of us in the audience to use one form of multimedia or electronic mail on a daily basis to make worldwide contacts. This was not always the case as recently as 1995. As early as the middle of the 1980s, there was strong evidence that the marriage between general-purpose computing and telecommunications was going to change the way the world conducted business in the future by integrating voice, video, graphics, and data into a single enterprise network. 3 issues that delayed global acceptance of this enterprise network of multimedia were direct government intervention, proprietary systems, and very high costs. In those early days of electronic media integration, most major corporations and governments used telephony and computing to send internal messages, but their systems were closed off to outsiders. So a firm like General Motors could not send an electronic mail message to a large parts supplier that may also have an electronic messaging system because they were not compatible. This was also the case for video conferencing. One of the leading video conference providers in the 1980s was Northern Telecom. They were the first firm to tightly integrate a telephone switch, commonly referred to as a PBX, and a general-purpose computer into a revolutionary product called the Data Voice 1, or DV1. The year was 1987, and this hybrid multimedia device could provide telephone services, computing services, and collaborative computing in a single device. Till then, it would have taken 3 devices to accomplish the same level of functionality. You may ask yourself, why had I not heard of this innovative multimedia device? I believe the primary reason was price. At that time, multinational corporations or the biggest governments were the only organizations that could afford to purchase these high-end multimedia platforms. The base retail price for many of these large systems was $500,000 for an entry-level system. And support services to keep the integrated information system operating was another separate cost. To put these early multimedia platforms in perspective, in 1985, you would have expected to pay $25,000 for a Wang entry-level word processor with limited graphics to text capability. In 1988, a Pentium-based PC with MS Office will cost you less than $2,000 and deliver not only word processing, but database management, electronic spreadsheet, presentation software, and internet access. Times have really changed. Looking back at the late 1980s and early 1990s, the market for electronic communications devices was still dependent on proprietary, high-cost multimedia platforms that were still the domain of those wealthy organizations that could afford the initial capital costs and annual maintenance contracts. Now, in the latter part of the 90s, in only a few years, beginning in 1995, the entire world has been rapidly gaining access to low-cost electronic devices that allow almost anyone to virtually communicate to most places on the globe. How did the world of communications and multimedia move from proprietary to open systems in such a short period of time? I think much of the credit will go in years to come to the rapid utilization of the Internet. What was once the exclusive use of the U.S. Department of Defense, called ARPANET in the early 1980s, has evolved into the Internet. What the Internet has done for electronic commerce and multimedia communication is to provide almost anyone global access to what once were proprietary communication systems used by government and large corporations. Now, an inexpensive information highway exists to send voice, video, and data across the world on a protocol standard called Internet Protocol, or IP. What the Internet is doing for the medium-sized businesses, individuals, and foreign governments is opening up global telecommunications to anyone with a modem, a web browser, and access to an Internet service provider, or ISP. In just a few years, this single communication protocol called IP has brought medium-sized corporations and smaller governments into direct competition and on equal footing with world-class organizations when it comes to global communications. Today, it is easy for me to see how the recent advances in computing and telecommunications have irreversibly changed the way the world does business at home and abroad. In 1998, I think that electronic mail, electronic commerce, and virtual private networks, or VPN, will be the defining office equipment products and services of the serious business enterprise, just as facsimile was years ago. For those of you in the audience unfamiliar with VPN technology, it is a new product offering from several international telecommunications carriers and ISPs that lets you order a private, secure, high-speed voice and data circuit based on your requirements. What this does for the average organization is deliver the ability to provision high-end telecommunications communications at an affordable rate when compared to previous product offerings. It is a perfect product for those organizations wishing to take advantage of new multimedia communications applications such as commerce servers or intranets that require high bandwidth for proper performance. However, before I talk about the common transport platforms for integration of telecommunications and computing, it is important to address the steps needed to establish a sound business process using these new technologies. It has been my experience over the years that many organizations become so involved in the magic of new technology that they see an easy fix to solve ongoing organizational problems. This then results in the organization losing sight of the business process or objective they were trying to achieve. For example, when on a consulting assignment, the first question I ask senior management is what are they and their organization trying to accomplish with the information technology? Are they looking to improve corporate communications, to reduce costs, to provide better customer service? There are a few primary steps to achieving telecommunications success for global competitiveness. In order to prepare for a successful implementation of telecommunications and multimedia technologies, a four-step process needs to be followed. The steps in the process, in order of importance, are these. First, it is imperative that a business or project plan be established to define what is going to be accomplished by the use of this new technology, such as implementing a virtual private network or VPN. For example, what business would expect from a VPN is the ability to electronically communicate with employees or strategic vendors in a secure manner using industry standard devices. This could include running Windows 95 as a client device over an Internet Protocol or IP that is able to talk to a secure corporate electronic mail server. All of these devices would be considered industry standard or off the shelf in that they can be purchased from any computer store or ordered from a computer catalog. Second, senior management needs to know the cost benefit of making or enlist a business technology expert that knows how this new technology will fit into the overall business strategy and who can identify benefits or cost savings. It is very important that senior management buy into and commit to the total project costs and timetable. It has been my experience that at least one senior executive needs to be the project champion. The third step is to develop a set of measurement parameters such as service level agreements or SLAs that will benchmark predefined performance standards on a regular basis to ensure that your telecommunications infrastructure is performing as promised. Just as business must have a financial audit, today companies need to have an information technology audit. Fourth, operate your new telecommunications systems in parallel with the older one before you make a complete changeover. Think of this change as an ongoing process that will continue to evolve over time. To accomplish this objective, it is important to use technology solutions that are not only modular and scalable, but purchased from a vendor that will stay the course. Let's talk a little bit about telecommunications services that support multimedia communications. Probably the most important aspect of multimedia communications is how this information technology is transported from here to there. Today, telecommunications technologies such as ISDN and frame relay are four vehicles that make this happen. Desktop video conferencing is a multimedia technology that has been gaining worldwide popularity with the help of ISDN as the transport mechanism. How it works is that video conferencing systems utilizing a single basic rate interface or BRI line that is common to each desktop provides a point-to-point video conferencing gateway. This method of video conference works well when it is a two-person conference. For a multi-point video conference, where there are several users on a video conference bridge, it is important to significantly increase the relative bandwidth with primary rate interface or PRI. An increasing use for ISDN is to use the multimedia capability of the broadband technology to deliver voice, data, and video communications during the same session. The general business term assigned to this method of communication is called collaborative computing or team collaboration. This method of linking various professionals in geographically diverse locations is becoming very popular with matrix and virtual organizations such as Anderson Consulting, CSC, and Deloitte & Touche. This merging of voice, data, and video into a single cable connection is a cost-effective way for many international organizations that may need to set up an international presence for a limited period of time. With ISDN BRI, our offices can be equipped with the data and two voice connections for the cost of a single voice connection. Frame relay is a proven telecommunications transport for voice, data, and video from 56 kilobits per second to 154 megabits per second and is very similar to T1. The advantage is that it costs less than a dedicated line such as T1 and is based on usage and measured by service levels. With this type of standards-based telecommunication connection, all carriers can commit to service level agreements, thereby providing a measurable unit of service. The primary advantage of frame relay circuits is that it delivers services in a low, consistent delay and high throughput at a committed information rate or CRI. This then allows the rate of information flow to be measured. The importance is that you can control levels of service and regulate bandwidth capacity. The advantage to buying telecommunications usage in this manner is that you pay for what you use. Asynchronous transfer mode, or ATM network technology, with its inherent scalability and applications flexibility, now is mature enough to become a viable approach for meeting multimedia requirements on voice, data, and video. It offers inherent scalability and applications flexibility. ATM is a cell-based, connection-oriented switching technology designed to support a wide variety of services, including ATM, frame relay, switched multimedia data services, MSDS, or circuit emulation. ATM transmits all information using small 53-byte fixed-length cells over broadband or narrowband transmission facilities. It is asynchronous because the cells carrying user data are not required to be periodic in nature, therefore not affected by transmission delays. ATM's strength in multimedia and its asynchronous nature mean ATM networks can carry both voice and data types of traffic simultaneously, with complete transparency to the applications. ATM was designed to provide large amounts of bandwidth economically and on demand. When a user doesn't need access to a network connection, that bandwidth is made available for a connection that is needed elsewhere. A virtual private network, or VPN, is a business-critical wide-area networking solution enabling an organization to securely and reliably communicate with its offices, business partners, customers, and employees. The flexibility and business-critical nature of VPN enable an organization to scale its business quickly, easily, and cost-effectively. Several studies show that migrating from private T1 to virtual private networks can generate cost savings of between 20 to 45%, even for relatively small networks. The service of VPN is emerging as a strategic product for Internet Service Providers, or ISPs. Even more important than the substantial cost savings are the strategic avenues that VPNs open up for an international organization. For example, a manufacturer in South America can use VPN networking to have a secure private connection with distributors in the European Community, the U.S., and Asia. A flexible, ubiquitous communications infrastructure that enables companies to pursue powerful new strategic initiatives, relationships, improve communication with offices and customers, lock in vendors and partners while creating barriers to competition, and develop and deploy new products with improved time to market. The use of satellite is becoming more affordable in comparison to landlines, such as frame relay and ISDN, for multimedia transmissions. The real benefit is that it is very effective for remote locations that do not have a legacy telecommunications infrastructure. In general, this is still an unproven delivery method except for the most expensive. As more global communications carriers enter the wireless world, one can expect the cost of satellite communication to decrease and the performance to improve. Cable modems are the latest rage in some U.S. cities. The service is provided by a local cable station who up to now have been the key providers of one-way communication, the television signal. At this time, this new telecommunications method is generally not available outside of major urban areas in the U.S. It is, as a new and as yet unproven multimedia delivery system, targeted more toward the home than the business population. Cox Cable is a cable company offering home access to the Internet. The advantage of cable modem is that it is very fast in downloading multimedia. Downloads are in the range of 10 megabits and uploads in the range of 2 megabits. Speed is an important, and if your only desire to download from the internet, then a cable modem could be the answer. On the other hand, if video conference, collaborative computing, and flexible media connectivity are a concern, then ISDN and frame relay provide a more universal solution. One leading ISP, Concentric Network, continues to push the envelope of converged networks and will be one of the first network service providers to widely deploy Internet provided, or IP, voice soon. Soon, companies large and small will be able to utilize an IP virtual private network for their corporate voice services, eliminating expensive PBX tie lines and switched voiced VPNs. You can expect other ISPs to compete directly with inter-exchange carriers, IXCs, such as AT&T Voice Service, by offering IP voice services that will deliver cost-effective, high-quality, intra-company voice communications, as well as affordable international voice calling. Let's summarize the current statement of telecommunications. On a global basis, the market is alive with information technology competitors of all shapes and sizes within the Americas, the European community, and Asia, offering a multitude of new products and delivery of advanced telecommunications services. This recent boom in the need to communicate electronically and virtually has been identified as a long-anticipated move from the industrial age to the information age. However, this move, like most historical changes, is not without limitations. One concern we have in 1998 on a global scale is the availability of properly trained IT workers. A recent issue of InfoWorld now estimates that shortages of 350,000 information technology jobs are unfilled today in the United States alone. So while the 1980s offered products that were out of budget for most of us, the latter part of the 90s sees a situation where the manufacturing of electronic devices that were out of reach for most businesses are now at commodity price levels. However, it is now becoming very difficult to find IT workers that can plan and deliver the services that are needed to be competitive in an electronics-based world-class economy. A case in point is the recent recruitment of the older, over 50 years of age, downsized information technology workers of the 1980s that are now heavily sought by major corporations and government. What is the reason? A single source of this turnaround in IT shortage is the year 2000 problem, which is now referred to as Y2K within the industry. Today, most of the world's computing and telecommunication devices still rely on computer program using COBOL. This is the unfortunate, since it is difficult to find young programmers that even know about COBOL, thus a new demand for the over 50 years of age programmers, at least until the year 2000. Another concern by business worldwide is that they need to rely on telecommunication networks to string together their far-flung enterprise with remote offices, strategic trading partners, or key suppliers is the assurance of levels of service. Service level agreements, or SLAs, are the new quality of service that is offered by major telecommunications such as AT&T, WorldCom, to name a few. Usually, telecommunications companies like an AT&T or Sprint would deliver your internetworking connections on a best efforts basis. This was fine when your business operations consisted mainly of voice telecommunications. If a line was disconnected, you would simply call back. This is not the case with multimedia communications, such as electronic data interchange, or EDI, video conferencing, or collaborative computing. As we move toward a virtual organization infrastructure where information technology is 25% or greater of the business process, it is important to have measurable levels of service. For example, inter-exchange carriers like AT&T, WorldCom, or Sprint all deliver world-class enterprise networks that carry not only voice but video and data. To ensure their business clients that their business communications network will be available whenever it is needed, the Service Level Management, or SLM program, is a way to measure the total availability. This is where you will be guaranteed a certain performance level of services, such as 99.9% uptime. If the carrier is not able to deliver the level of service agreed to you, you receive a chargeback from the carrier in the form of cash payments. As we move toward the year 2000, service level agreements will be as common as current business practices. The reason for this is that as organizations are not so much defined by where they are, but what they do. Today, it is extremely important for a world-class manufacturer to provide accurate dates of delivery to buyers and distributors. If the manufacturer relies heavily on several subcontractors to deliver their components to produce a final product, then any delay in a component is crucial toward meeting the delivery schedule. A breakdown in telecommunications between this virtual manufacturing consortium could be very costly if deadlines are missed. Now we know that as businesses and government rely on independent telecommunications carriers for their global communications, it is imperative that they understand that any downtime on a carrier's network will impact their business and communications infrastructure. This is just the beginning of a new age of communications where service providers, from telecommunications, internet access, and outsourcing suppliers, will need to monitor their telecommunications networks over a 7-day per week, 24-hour per day. Industry experts believe that all levels of measurement will include availability of the telecommunications network and latency of the network. Latency is a very key factor that is crucial to properly deliver multimedia services such as video. In order any conference such as this one to properly transport over hundreds of miles on a telecommunications network, it must be delivered at a constant latency. If this condition is not met, the receiving end will experience poor voice quality, and dropped video frames will cause a delayed image. Another concern for business and governments, as they rely more and more on electronic communication, is security and privacy of electronic transmissions. For this very reason, a growth industry is occurring in the fields of network and internet security. The typical solution for a secure network session is set by using strong authentication. What this means is that the user is required to log on to a network device using a logon and password. This is the first level of authentication. Next, the actual link between each network is encrypted for 56 to 128 keys. This final phase guarantees that during information transmission, no intruder can decrypt the private information. Companies like Secure Dynamics provide what are known as secure tokens. This device looks like a credit card, but it actually provides a secure logon number that changes every 10 seconds. In this manner, it is very difficult for unauthorized users to penetrate a private network. Another provider of secure network devices is Ascend Communications in Santa Clara, California, that is the leading provider of remote access servers, or RAS. These servers are normally used by businesses and government to allow only authorized users to log on to a private network directly from the internet, analog line, or ISDN access. It is becoming quite common to see an Ascend network device connecting both ends of a virtual private network. Service management has become the new industry buzzword, yet there is no universal interpretation of its meaning. In general, service management represents a comprehensive approach to managing the IT infrastructure for the delivery of business-critical information services. This approach is based on a methodology that is a set of process and management tools for delivering services to business units at agreed-upon performance and cost targets. In general, service management requires clearly communicated expectations between the business units and the service delivery organization regarding the availability, and performance requirements of the business units. The first step toward successful service management then is for the business unit to provide IT with an understanding of customer business requirement in order to derive a strategy that enable IT to manage the business objectives. Second is to translate the IT strategy into planned IT services, well-defined service objectives, and service level metrics. For example, between the hours of 7 a.m. to 7 p.m., Monday through Friday, our telecommunications network will be available 98% of the time. Third is a step to require the IT organization to develop, test, and deploy those defined IT services. And finally, the fourth step consists of the activities that the IT organization executes to keep the enterprise environment operational. These activities include proactively collecting resource status data, managing all the event problems, customer